If you look at the night sky, it's easy to imagine planets drifting randomly through space, but in reality, their motion is extremely structured. Every planet follows a predictable, repeating path around the Sun, an orbit that stays remarkably stable over billions of years. This stability isn't accidental, it comes from the natural interplay of gravity, motion, and geometry. When these ingredients line up correctly, a planet settles into a long-lasting orbital pattern that barely changes across cosmic time. The first key ingredient is gravity. Everything with mass pulls on everything else, and the Sun, being 330,000 times more massive than Earth, dominates the entire solar system. Its gravitational pull constantly tries to draw each planet inward toward its center. But planets aren't just sitting there being pulled, they are moving sideways at incredible speeds. Earth, for example, orbits the Sun at about 30 kilometers per second. If this sideways motion didn't exist, gravity would pull Earth straight into the Sun in a fiery spiral. An orbit forms when these two effects, inward pull and sideways motion, reach a perfect balance. The planet is always falling toward the Sun, yet always missing it because its sideways speed is just right. It's similar to swinging a ball on a string, except the string in this case is gravity. The actual shape of an orbit depends on this delicate balance. Most orbits are nearly circular, but technically they are ellipses. This shape reflects the conditions under which the solar system formed, when dust and gas collapsed into a spinning disk around the young Sun. A stable orbit requires the right combination of speed and distance. If a planet moves too slowly for its distance, it will spiral inward and crash into the Sun. If it moves too fast, it will escape the Sun's gravitational grip entirely. Each planet has settled into a speed that perfectly matches its location. This is why closer planets like Mercury move incredibly fast, completing an orbit in just 88 days, while distant planets like Neptune take 165 years. The farther a planet is, the weaker the Sun's gravity becomes, and the slower the planet must move to remain in balance. Another important factor is the sheer emptiness of space. Planets are unbelievably far apart relative to their sizes, so they rarely come close enough to disrupt each other's orbits. Yes, they exert gravitational tugs on one another, but these small influences usually average out rather than causing instability. There are still subtle shifts. Jupiter, being by far the most massive planet, slightly nudges the orbits of its neighbors over millions of years. These small perturbations create wobbles, but nothing dramatic enough to threaten the long-term layout of the solar system. Even the Sun itself isn't perfectly stationary, it wobbles gently as the planets pull on it, especially Jupiter, but these movements are tiny compared to the system's overall scale and have no significant impact on orbital stability. In the end, planets orbit the Sun stably because nature discovered a perfect equilibrium. Gravity holds them in place, sideways motion keeps them from falling inward, and the vast emptiness of space prevents collisions or major disturbances. It's a finely tuned cosmic dance that has lasted for billions of years, and will likely continue for billions more. That's it for today's video. If you enjoyed exploring with me, don't forget to subscribe to Science Lab, where we turn everyday things into scientific discoveries. See you next time.